All right, so this is a problem from Educative. It basically looked up a bunch of these patterns that underlie many of the problems on LeetCode because I'm not that great at them. I like to improve. So this is like a course that actually covers a lot of those patterns. And this specific one is the sliding window technique. It's basically like when you get problems that are dealing with like finding a subarray within an array that meets some conditions, that subarray meets some conditions. Like this is a common pattern that you use. Anyway, so I'm trying to like get better at identifying those kinds of problems, and the course has a bunch to solve. And so here's that one. It is to essentially you're given an array with a sum, and you are trying to find the smallest subarray, contiguous subarray. So like it can't be like 2, 1, and then 3. It has to be 2, 1, 5 or something. The smallest contiguous subarray where its sum is greater than or equal to the sum that you're given. So I first did a brute force solution where I'll uncomment it so it's more legible. I basically did a brute force solution where I'm essentially creating a window at every single, iterating through the array, and then at that particular index that I'm at, creating a subarray from that index onwards, and slowly like increasing it until I find one of those subarrays that has a greater sum greater than or equal to the target one. And so that's like O of n squared, time complexity, and not ideal, but it was just a first solution. I didn't even think, I was like, oh, this is the way it wants us to do the sliding window. But then I realized, we want like an O of n solution, which is this right here. It's basically you are taking it's almost like a slinky rather than like a sliding window. Like it extends, you extend it, you're searching for a subarray that is that has a sum that's greater than or equal to the given sum. And once it meets that criteria, once it finds a sum that's greater, it starts reducing the size of the window, or the slinky starts to shrink until it gets below that target sum again, and then you start increasing the right side once more. So you're iterating through the array, and at each new loop, you add the next element of the array to your particular sum, and then you start once your current sum is greater than the target, you get the current size of the current subarray, so the index you're at minus the starting index, which starts at 0, and then you check if the current size of the subarray, if your current subarray size is greater than your answers, which is going to be 1 greater than the length of the array that you're given. And so ideally, any subarray is going to be smaller than that, so it's going to replace it. And then it removes the furthest left element of your current subarray, and then it increases the left side index value by 1 as well. And then so it keeps looping. So it keeps going through the rest of the array. So it increases like the right side of the window, the sliding window. And then if you get through the whole thing and you never replace the original answer that you started out, which is this like dummy value of like 1 greater than the length of the array that you're given, then the problem wants us to return 0 if like no subarray is found. Anyway, so that's the solution. Tested it a couple times just by printing it. There's probably a better way to do this, which I should look up. But yeah, that's about it. So hopefully by doing this, I can continue to improve how I talk about solving these problems.